A few weeks ago, I showed you how I 3D printed these enormous transformers by Toymaker 3D, and that they're free for you to download and 3D print for yourself. But the biggest challenge that I had was because I scaled these up by 300% of the original size, a bunch of the joints were really loose. And I had asked for your suggestions and feedback on how I could potentially resolve that. And that's exactly what we're gonna be doing in today's video, is testing out 14 different suggestions that you provided me and seeing which ones work the best. Also, Megatron here just like can't even stand at all on his own. It's just so, all of the joints are so loose. Optimus Prime's a little bit better off, but he's still pretty loose and has a hard time maintaining any sort of pose other than him just kind of standing up straight. And in that initial video, I ended up using nail polish, which is the way that I was familiar with or had seen previously online of how you can stiffen up your joints. And I ended up going through, I think it was almost 2 bottles of clear nail polish to try and stiffen up the joints. And it's because these files are scaled up so large that the tolerances in between the parts are so much bigger. So it's still having a hard time gripping and maintaining the printed parts on top of each other. And there were a lot of amazing suggestions that you provided, and I tried to narrow it down to a complete list of something that seemed achievable and things that you could easily do if you have a 3D printer or have access to something like a Walmart or a Lowe's where you can pick up some different supplies that we'll be testing out. So in order to test this all out, I need to 3D print a whole bunch of different joint pieces. So I'm gonna be focusing in on the leg of Optimus Prime and jumping on my Elegoo Neptune 4 3D printers to 3D print a bunch of these parts, which just so happens to be the sponsor of today's video. Elegoo is the maker of these Neptune 4 3D printers that I've used to 3D print Optimus Prime and Megatron and all the different parts that we're gonna be testing for this video. If you're interested in a fast and affordable 3D printer, Elegoo has a variety of options available to you, ranging from the Neptune 4, the Neptune 4 Plus, and the Neptune 4 Max. And they also make some great resin 3D printers, and it just so happens we might be testing out with some of their resin for one of these tests. More information about Elegoo's products are listed down below. Yeah, this is just a lot of 3D printers. It's ridiculous. And like I previously mentioned, I'm gonna be focusing in on the leg because that seems to be where the loosest parts are for me. It also has a wide variety of different styles of joints that we're gonna be working with. Everything from these little dual, I think they're like elbow or knee joints, to here is the ball joints that we typically see with a lot of different figures, to these joints that allow you to pivot on the hips, which again have a completely different design. One other thing that I did was I've actually cut up the leg into a few different parts just to help reduce some of the amount of printing that I was gonna be doing. I wasn't gonna 3D print the entire leg at 300% scale over and over and over again. That would just be a huge waste of filament, and I definitely went through a lot of filament to print out all these test pieces. And the first one that we're gonna start with is 3D Gloop. Now this is an actual adhesive for your 3D prints that allows you to chemically weld the parts together. Now individually, you should be able to apply this in some thin coats directly to the 3D prints before combining them together to add a little bit of layering to those 3D prints. The benefit of this is that it should add a lot of durability to it. Also, this cures relatively quickly here, so it's not gonna take a few hours like we have with some of the other products that we're gonna be testing. And I did go ahead and do a 1 coating versus 2 coatings for some of these as well. All right, so here is the single coated Gloop. I've also labeled these as best I can. That is still kind of loose, but it's at least stiff enough to where it seems like it's holding the position. So far, this is already better than the nail polish that I was applying previously. Here's the part that I've coated with 2 coats of Gloop, and we'll try and shove that in place here. Oh my God, there we go. Funny enough, that feels even looser for some reason. I don't know why that is. I would have thought with 2 coats, it would have been, you know, held onto it even more snugly inside of the joint area, but this is definitely a lot looser than this one here. This one feels really stiff. Man, it's so stiff to get that in there. That's a lot stiffer with the 2 coatings here. This is on the upper thigh and then the knee area, or the lower leg and knee area. Then let me put the upper thigh piece in. Again, that's a good bit stiffer, but not super stiff. Already though, that's significantly better than what I had previously. With the 3D Gloop, I think this is a potentially viable option, especially if you're already 3D printing and maybe you already have 3D Gloop on hand. Definitely worthwhile trying to apply a coat or two and seeing how well that'll stiffen up the joints for you. This is right here, this is a really great option. The other really good thing about this as well that I'll cover with some of the other options is it goes on clear. So you don't have to worry about it, especially for something like this, these colored legs here, where I have to worry about a different pigment going over the white or the blue and showing through when I'm posing the figure. The next option that we're gonna be testing is Plasti Dip. Now, normally this comes in a sprayable form, but it's also available in this liquid form. I picked this up at Harbor Freight, and you can actually either dip your print directly in it or use a chip brush or maybe a Q-tip or something like that to apply it directly to your print. Now, this is rather messy and it does go on thick, so I'm gonna be interested in see how this actually turns out. And also, we're gonna need to let this sit overnight for at least 12 hours before we try and test it out. And just like with 3D Gloop, I did a 1 coat versus a 2 coat just to see how it might compare. So here, let's stick this in. That is super stiff. That is really stiff. All right, I can already tell though that it's starting to peel away at the Plasti Dip the more that I move it. So this might be a decent, I mean, it's still really stiff though. Holy crap. Yeah, I can already see it eating away at it the more I rotate it around. Should I even attempt the second coat here? There's no way that's going in. That's not going in. 2 coats is too much. It's too much added onto the actual joint for this to work. Now, here you're gonna see where I've separated the part where I wasn't even able to fully get it on, but it was already eating away at this rubber exterior that was applied to the print. So, I mean, that might be a good temporary solution for you. Obviously, the other big challenge is it's not the same color. So anytime that I have this joint and I paint this on, unless I'm very precise and keep it to a very small amount, you're gonna end up seeing that black material in the joint area. But that is a super tight fit. Also, I managed to get it on the exterior of the print, which I would have not been a big fan of if it was my actual project. The next one that we're testing is liquid tape. Now, I've never worked with this stuff before, but it seems like it kind of is like Plasti Dip. I'm gonna be interested to see if it holds up a little bit better. Both of these materials, I should mention, you definitely need to be working in a well-ventilated area because they are very stinky. And after letting that sit overnight for over 12 hours now, we have 2 different parts, again, one with 1 coat, one with 2 coats. We'll be interested to see if they actually fit. But here, we'll try the first one, and this is the, there we go. Oh, that's a nice tight tolerance. And let me see. It's wearing away, but nowhere near as bad as what I was seeing with the Plasti Dip, where the Plasti Dip was almost just peeling away from the exterior of the print. Here in the joint, this is holding up really well to a bunch of this movement. Oh, there we go. It now just started to peel. So maybe I just needed to move it around a good bit more. But you can definitely see where after moving the joints back and forth, it started to wear away from the rubberness of this. But it's holding up, I think, fairly well, and even some of that gunking action might end up lending itself to making those joints a little bit more posable for you for at least a short term. Yeah, the Plasti Dip just easily comes off. At least this has bonded a little bit more to the print, and it seems like it's a little bit more durable of a material. Also, I did end up getting the 2 coats of the liquid tape part in there, and it barely budges. One that was suggested that I never had heard of before is using floor polish in the joints of your action figures. Apparently this is very popular, so we're gonna test this out. I actually had this Pledge Revive It floor polish on hand, and I ended up going out and purchasing Rejuvenate Wood Floor Restorer based on a video that I saw of D-Star01 here on YouTube. And one thing that's a little bit different than the other tests that we've run so far is because these are liquids and they're really thin, and we're gonna be brushing them into both of the actual joints of the legs, not just the pivot points here, the actual joints, but the where they're actually gonna connect in the other parts. All right, let's take a little bit of the Pledge Revive It, and I'm gonna pour that into this little cup here. Should be able to get some on my brush, and I'm just gonna paint it directly onto the print. It's obviously very liquidy here. It's almost like water. So it's gonna be making a little bit of mess, which is why I've got this mat that I'm gonna be setting the parts down on. Now this does need to cure overnight for about, again, 12 plus hours before you can start really using it. And then I'm gonna do the same with the Rejuvenate, which kind of looks like milk. Again, just using a different chip brush and brushing this on, clearly making a mess this entire time here. Now these are going on really thin, so I'm not sure how well this is gonna work with the tolerances that we have, especially after scaling the parts up and seeing if this will accommodate any of the gappage that we have in our prints. All right, so these have sat overnight for about 12 plus hours here. So we're gonna test out the Pledge Revive It first. Now, apparently this takes multiple coatings. I'm just gonna do the one and see how it goes here, but we'll test this out. I mean, that's relatively stiff. That's honestly a pretty good hold. It's not as stiff as some of the others, but it's significantly stiffer than just the standard prints rubbing up against each other. Also, I think I forgot to mention that these smell really good, especially compared to the ones that we were working with previously. Honestly, that's not horrible. It probably would benefit to do 2 coats on this. I can see now why it's recommended to do 2, because there's a little bit of contact there, or I should say a bit of contact, but not maybe as much as I'd like to see. And actually that's wearing down a little bit more. Yeah, unfortunately, the ball joint is still really loose. Now let's test out the Rejuvenate to see how this goes. My big thought around these is that they're so thin that I'm not sure it's really gonna make that much of a difference. I mean, that's relatively stiff, but not super stiff. I think both of these could do for multiple coatings potentially if you wanted to attempt these. Maybe you already have this on hand for your regular action figures. It might work, it might not work. I don't entirely know here. So then this is supposed to be the definitive guide here, right? Honestly, I think these are just so thin for these upscaled prints that it's gonna be hard for these to work relatively well without a lot of coats. And the problem is it takes multiple hours for these to cure. So you're looking at, I don't know, 2 days, potentially 2 to 3 days, depending on how many coats that you want to apply to these. This probably works really well for your standard action figures, but maybe not so much for these larger upscaled prints. So I spent the past few days applying a few more coats of Rejuvenate and the Pledge to these same prints. So there's now 3 coats of them on there, and I'm not really seeing any major difference. Maybe it's because of how large these are scaled up and how thin the liquid is on the coating that's being applied to these. It's just not gonna work when you're scaling up things this large. It's probably a great option for your standard action figures, or if you already have something that has a really tight tolerance but is loose, it's worth trying that out. Another really popular idea was to use UV resin that you might resin 3D print with. So here I've got some ABS like Elegoo resin. This is in gray. Potentially you could use clear if you have clear on hand. I didn't have any, so I'm gonna be using this gray resin, and we're gonna pour it into this little container and then use a chip brush to paint it onto the prints. And then we can take a UV pen or just a UV light to almost immediately cure the resin directly to the 3D print. Now, if you don't have a UV pen, you could just set these outside directly in the sun for a little while for them to cure. I'm also gonna place these directly in my Elegoo UV curing chamber for 2 minutes just to make sure that they're properly cured. Now this is just with 1 cured coating of resin directly on the prints. Now what's great about this is that you could quickly go in and thicken this up even further with more coats in a very short amount of time. Obviously the downside is here I used gray resin, so it's gonna peek through a little bit depending on how messy you are with your application, but so far it's not too bad with the gray that I've used directly on the white or the blue prints. This is honestly pretty impressive with just one coating of this ABS-like resin directly into the joints and then cured. That is fantastic. That is super stiff as well. It's gripping onto itself so well. So here's one potential problem with this. So I tried using the hip joint here. I cannot. After placing resin directly on the joint area, it's modified the shape a little bit too much, and I'm having a very difficult time getting it into the other corresponding part. That's not going in at all. You've definitely got to be very precise with the application of the resin. One of the other benefits, well, at least for me, is this is a bottle of resin. I think it goes for like 20 bucks or less for the smaller one here. And again, should last a very long time since you're just going to need a minimal amount to go into the joints of your prints. The other thing is that it's just how quickly it will be applied and that you could build it up depending on the tolerances of the prints. But this was just a one coat thin application and it worked really well. And so far, all of the methods that we've tried have been requiring us to paint on the materials directly to our prints. But what about the idea of modifying the geometry of our 3D print files to actually increase the tolerance between the joints? And the first one that we're gonna test out is applying a fuzzy skin to the 3D print. Now, we don't want the fuzzy skin on the entire exterior of our printed part. We just want it on the contact area of where the joint is gonna connect with the other part. So what I did is directly in Orca Slicer is using the modifier function that I showed you previously. So we take our part and then I can create a modifier and scale that up and fit it directly against the part where I believe the hinge is gonna connect with the other part. So in this case, it's the little ball areas on the side of the print. And then I can go into the other panel and select the fuzzy modifier and enable that. And then I can also do that for the other part, for the ankle ball joint, where I can take a sphere and add that as a modifier and apply that directly to only the upper portion of that actual part. And then once they print, you can see that they now have a texture directly on the areas that we modified, while the other sections of the print are still nice and smooth. In theory, this should give us some nice texture detail for the print to grip onto when it's inserted into the other part. That's a pretty good snug fit. It's definitely added a lot more grip to the joint area of the print. I'm not sure how long that will last or if it'll eventually wear down. I'm assuming the constant rubbing back and forth will potentially wear that down a good bit. Actually, that's working extremely well on these joints. It's a really solid connection. This one's loosening up already a bit, but this one's still pretty tight. Yeah, that one's, it's better than what it originally was, but it's still fairly loose compared to some of the other options. I mean, it's a viable option. It's definitely better than the original set that I had printed without the fuzzy skin, but it's a viable option because you already have these filaments and you just need to make a minor modification to the files, and it's going to add a little bit more grip to those joints for you. So it's certainly something to consider. And the next test is the one that I think I'm the most excited to test out, which is the theory of enlarging the actual joint file so that it has a better connection area within those other parts. Now, one other thing that's really cool that you can do directly in some of these slicers, like Orca Slicer, which is what I'm primarily using to slice these files, is I'm not only enlarging the area of the print. Now, I don't have direct control over the specific area that I want to enlarge. That I think I'd have to bring in directly to a 3D modeling software. So I'm just gonna be trying to modify the X, Y, and Z, potentially just to help enlarge some of those slightly. But what's really cool is to keep track of all of the test prints that I'm about to test out, I have applied a text modifier directly to the print. So as you select the file, there's a text modifier option at the top of the menu. Then you can apply your text and then imprint that directly onto your file. So I have these files modified in 5% increments here, ranging from 300 all the way up to 325%. All right, so after doing some quick testing here, the largest that I was able to fit in this. So keep in mind, my prints are scaled up to 300% scale. You're definitely gonna have to test this out on your own, depending on the parts that you're working with. But bumping this up to 310%, and slightly modifying the X, Y, and Z axis accordingly is what is going to give me the tightest fit that I was actually able to get into the corresponding joint. I was not able to fit the 315 or the 320 or obviously the 325 that I had also modified and printed here. But this is perfection. I'm honestly kind of blown away. This option right here is really good. I think one of the biggest challenges that you're possibly going to run into when trying to do this and test it for yourself is, like me here, I've applied a smaller print to one of the, the joints there, and I just can't get it out. So you might end up printing a bunch of the different parts, and you're going to have to test these out before doing the full assembly. This also makes me a little bit concerned of how I'm going to break down my Optimus Prime and Megatron to get them reprinted and assembled in there. I could always try and break the other prints and remove them that way. But this is so good. That is the amount of friction right there is so good. Another fun printable option is by using TPU to create a little skin sleeve that will directly go over the joint area of your prints. Now you could do this using a variety of different methods or tools like Mesh Mixer. I ended up bringing my files directly into 3D Builder on a Windows PC and then using the hollow function and setting that to 1mm to hollow out the file. I then used the trim function to actually separate and trim off some of the areas because I'm just looking to create this little cap that will directly slide over the parts. Now the challenge is going to be one, that you need to have TPU to print with this, which can be a little bit finicky to work with. The other is that this is definitely not going to work for all of the different joint styles that your print might be working with. As an example, this little hip joint here, there is a TPU cover that I printed and it will just not go on and stay on that print, especially with how this is designed with that little angle slot. No matter how I put this on, it just wants to pop right off. You also need to have these scaled up quite a bit, so I'm not even sure that they're going to fit inside the corresponding area once they're installed. You also definitely have to play around with the tolerances and the scaling so that these fit properly, but it is rather satisfying snapping those on into place. All right, let's see if we can even get these. There's no way any of these are actually fitting directly into those joint areas. The only thing that I could think of that would potentially make this work is that if you scaled the joint file down in size, and again, you'd have to figure out by how much you need to scale this down by in order for you to then create a TPU sleeve of that for it to be able to fit into this joint area. This just isn't, it's gonna be too much of a hassle, in my opinion, to get this to try and work. So far with some of the other methods that we've tried just have been a lot more predictive or reliable for you to work. Even the small, look at this is the big opening here that's supposed to go into the upper, I think upper leg or lower leg. And here's the smaller section, and the smaller section doesn't even fit into there. But it's still fun testing out creating these little TPU sleeves that go directly on your prints. Unfortunately, I'm gonna say the TPU option's a bust unless you really wanted to go in and try and fiddle with this a lot more. Also, if you made it this far into the video, I don't normally make these longer style deep dives, but it's been a fun process, so thanks for hanging in there. I also want to say a big thank you to all my Patreon supporters for your continued support of me making wacky videos like this one here. If you're interested in things like my 3D printer settings that I used for these 3D prints, you can find those over my Patreon. So the next set of tests have to deal with tapes that you could apply to the joint areas to increase the tolerance or friction between the prints. The first one that we're going to test out is this aluminum foil tape. So you can basically take a piece of this aluminum tape and then peel off the backing and then start applying it to the different areas of the print to help build up some of those tolerance areas. The other thing that's kind of cool about this is that it's not a smooth, once you're applying it, it's giving it a little bit of rough edges to this. So it I'm guessing gonna help grip some of the other areas of the prints. It's also sticking to these PLA prints fairly nicely. I also ended up applying a little bit of it into the connecting area of the corresponding print. This aluminum foil tape honestly has kind of blown me away. I was not expecting this to work as well as it did with these prints. For whatever reason, I just thought this wasn't going to adhere or work very well. It is fantastic. It is really easy to work with. You can easily manipulate the foil to go into a variety of different spaces. You can trim it up to be as small or as large as you want. You don't even need scissors. You can just use your hands and tear it. And it's sticking and adding a whole lot of resistance to these joints. This is fantastic. Honestly, this might be one of my favorite options that I've tried out here so far. Also, I think this was about $6 or $7 for this roll over at Harbor Freight. So very affordable, should hopefully be easy enough to find at pretty much any hardware or Walmart store or anything like that. The downside, I would say, with using something like this is you've got to be very precise with how you're applying it. You'll definitely see some of the aluminum foil poking through or that metallic, but maybe that'll work with some of the different prints that you're working with. But just depending on how you trim it down, this could be a fantastic option. I was not expecting this. This was a very pleasant surprise. So the next one we're going to try is Plumbers Tape. This doesn't really, it sort of sticks to itself. So you're going to have to take your print and wrap it around it multiple times for this to stick and to hang into place. I'm not exactly applying this cleanly. This isn't going to work. I'm pretty sure this isn't going to work because typically what you're using this is with the threads of a pipe, and it's going to really get into the recesses of the threads of the pipe. But on these smooth exteriors of the prints, it's not really adhering to anything. So it's just kind of loosely flailing around. Let me try and shove at least this one end into one of the prints to see. I'm not a big fan of this one. And in fact, it's just moving the thread tape around inside the joint. I'm going to call this one early. This one's a bust. I would say don't even bother with the thread tape. Nice part is it's super cheap and you more than likely have some of this laying around if you wanted to try it out for yourself. But Uncle Jesse, you're not using the thread tape correctly. Yeah, I'm sure I'm not. Let me know in the comments of how I should be applying that to these smooth prints and it to actually stick to itself. Next, we have tread tape. Now, this wasn't actually anything that anyone suggested. I just happened to see this while I was shopping for the aluminum foil tape, which I didn't know was an actual thing, which I probably should have. But yeah, this is a textured grip tape that you should be able to, I'm assuming, stick to a bunch of different things. So we're gonna do basically the same thing. I'm gonna try and take strips of this and peel it away and stick it into some of the areas of our prints. This tape is definitely a good bit thicker, so I'm not sure it's going to. Yeah, that's not gonna, unfortunately, it's not gonna work. Look at it, I'm just trying to get this into the part and it's already shredding and ripping the tape away from the print. Here you can even see where I was trying to force it against, this side has tape to tape. So I figured maybe it would help rub against each other, even though it was gonna be a little bit thicker. And it's just completely eating away at the tape as I'm trying to insert it in there. It's also getting all these little flakes everywhere. This is basically like sandpaper. I had high hopes for this one, but unfortunately the tread tape is a bust. The next one that we're gonna be testing is some black electrical tape. So I've got this taped up. Let's try it out here. I've got tape on the outside and inside of these. There's a lot of friction now and it's holding in place really nicely, but I can definitely see where the tape is no longer adhering and coming off of the prints as we continue to move it back and forth. But it might just stay trapped in there and still continue to provide a lot of friction. Now, this one that I picked up is a little bit more on the expensive side. It's the Scotch Super 33 Plus. It's supposed to have some extra adhesive qualities to it. Maybe for non-3D printed things. But this is a pretty solid option here for you to test out. I'm not sure how long this is gonna hold up in the long term, but it's definitely providing a lot of friction in there and it's relatively easy to install as well. This is honestly a pretty good option. We're down to the last two tests. This next one is gonna be using foam sheets that you can find pretty much at any craft store or Walmart or like a Dollar Tree. These are really thin foam sheets of craft paper that you can easily cut up, and we're gonna try and glue those into some of the joints. You also wanna pay attention, there are varying thicknesses to the sheets that you can buy. More than likely, you're gonna wanna try and find the thinnest option that you can, depending on the print that you're working with. Now, unlike some of the other tests where we were manipulating the hinges, here we're actually gonna be taking some thin strips of this foam padding and super gluing it into the corresponding parts of our prints where the hinges are gonna be inserted into. This way, it should add some friction to them versus just more easily rubbing off of some of those ball joints. That's actually pretty good. Oh man, that's actually really good. That worked so much better than I thought it was going to. So again, I just glued the foam pads onto the side of the part where the hinge is going into, and it's a really nice stiff pivot point here. Yeah, man, that is a great option. And these are really cheap. These are like 99 cents, $1 at Joann Fabrics. You can buy them in bulk from Walmart. This is a fantastic option here. This is really good as well. Honestly, this is a pleasant surprise. And the last one that we're gonna be testing is utilizing a hot glue gun to, you guessed it, try and apply some hot glue to the joints. Now, I'm honestly not sure what's the best method of going about this, about pre-applying it and then assembling, or assembling it directly into a pre-assembled joint system. So let's test both. So here's our pre-assembled joint. So let's apply a little hot glue in there. I'm not honestly very confident in this working very well, but it should be interesting. I'm just gonna try and squeeze a bunch of this in there and move this around to try and gunk it up a bit. Oh my gosh, that's actually providing a lot of friction in there. I think my glue gun is up too high as well. Applying it directly to the print before inserting it seems to be the better option. I'm just applying a little bit of hot glue there, and then still, while it's relatively warm, inserting it in. What's nice is I think I should be able to, like this one up here is still a little loose, so I could probably try and squeeze in just a dab of glue in there and then move it around to increase some of the friction. And let's try the ball joint, which is always the tricky one. I think it's just because it's so round and smooth. Yeah, it's definitely, you can see it all gunking up right there. That's not the best look for your figures. Using a hot glue gun is definitely a bit of a mixed bag when it comes to the results that I'm seeing. In this case, where I pre-applied the glue to the hinges and then installed them while they were still a little warm, it is a nice, clean, stiff contact between the parts. I am seeing some of the glue residue peeking through on the sides or building up and coming out as I move it around. The foot joint here is probably the worst offender, where you can clearly just see it coming out and bunching up as I continue to work the ankle joint around. It's certainly not the worst of the options that I've tried out so far, but it's definitely not the best. But what's nice is more than likely you already have a glue gun on hand and can test this out for yourself and see how it works for your project. Now, I've gone through and tested a bunch of these options, and here are my top 5 results that I would choose if you were gonna be 3D printing and upscaling your parts for articulating 3D prints. The first one is adding a little bit of resin to the joints of your 3D prints. The tightness of this can be easily controlled by painting on and curing a little bit more. It's easy to speed up the process by painting and curing versus having to wait 24 or 12 hours for some of these other products to cure. It's gonna allow you to really go in there and test these very easily. The downside is, unless you have a clear resin, you're definitely gonna see those, but so far these are holding up pretty nicely and the joints are really nice and stiff. Also, anytime that you're working with uncured resin, make sure you're wearing the proper PPE. Another great option is craft foam. It's really affordable, easy to access, available at most stores, and you can easily glue it in place into the corresponding joints of your prints, and it's gonna help stiffen up those particular areas that you're looking to articulate. This is a fantastic, affordable, and quick to access option. One of the no-brainers that just works really well is trying to test out and enlarge the joints that you're going to be applying to the prints. This, again, it really helped increase the stiffness of these. It might not be as good as some of the others that I've tested. Like this one here is already starting to loosen up just a little bit. So maybe I should apply some pledge to this and test that out. But it's a valid option that you could definitely consider because you're already going to be 3D printing these. The only downside is that you're going to have to experiment with the scaling to see what's going to fit best with the particular prints that you're working with. And I would say the one that surprised me the most was liquid tape. I've never worked with this before. I honestly didn't think it was gonna hold up very well. This is working fantastic here inside these joints. Really stiff. It is still kind of eating away at it a little bit, but nowhere near as severe as what I was seeing with the Plasti Dip when moving these joints around. Again, one of the downsides of this is you have to wait for it to cure a bit before you can move them around, but also it's in black, so you might be able to see it depending on how you have your figure posed. Now, these weren't necessarily in any sort of ranked order, my top 5. However, this one is probably my favorite out of everything that I tested, and it was easily the biggest shock to me, and that is this aluminum foil tape. This just works so incredibly well for adding friction to the prints in every area. It's so easy to tear off and get it to the size that you need and apply it to the prints. It's sticking extremely well. It doesn't look like it's breaking down or anything like that within the prints. The only downside is, again, depending on how you have your figure posed, you're potentially going to be able to see the aluminum tape that's there. But if you go in with an X-Acto knife, you might be able to trim away any of the excess flashing that you might see from maneuvering that around. And what's great about all these different options is that you're not limited to just using one. If you wanted to mix and match these, you can certainly do that to achieve the desired results that you might need for your specific project. And that's exactly what I'm doing with this project. In some areas, I might be using the aluminum tape, in other areas resin, and in others, I might be using some of those foam pads. The articulation on these is so much tighter now after going back through and updating a whole bunch of the other joints. I still have a few key areas that I need to touch up, but I am so far extremely impressed with how well this has worked in a bunch of the areas. Now, I did, again, mix and match some of these different techniques. So I used the aluminum tape on some of the joints. I ended up using resin in some of the other joints, and then I even combined them in some other areas where I used a little bit of the resin as well as the foam padding. Another thing that you want to consider that I wasn't even thinking about is just how top heavy some of these, when they're scaled up, can actually be. Like you'll see here, Megatron still wants to lean back and fall over. I've gone back in and strengthened up the knees a good bit, but it seems like I need to go back in and just add a little bit more to make them really tight so that he's standing at a much firmer stance. Optimus Prime, on the other hand, is pretty much good to go at this point. There are definitely a few areas that I want to go back through and touch up, like the waist here. I did not update. So you'll see here he's freely swiveling, but everything else is a really nice, firm joint area of articulation, other than the waist at this point. And one other great tip that one of Customs over on Instagram gave me is to take some of those foam sheets and cut them out and apply them to the bottom of the feet. This way, they're a little bit more grippy for your tabletops and aren't gonna slide around as much. Megatron, I did not apply those to, just to show you the difference, and he just wants to skate across the tabletops here. And I'm just loving how tight the shoulder joints are now that I put resin and foam in those spots to hold them in place. This, you know, it's a really tight fit. And if you made it this far into the video, I wanted to sincerely say thank you so much for watching, and hopefully you learned something along the way here while experimenting on different techniques to stiffen up the joints here. At least I can now get these in a figure posed manner that I can have on display somewhere here in the studio, or just run around and play with them. I wanted to say thanks so much for watching, and hopefully you enjoyed, and I'll see you next time.